So now we're going to solve some inequalities. So first of all, you'll have to remember the different types of numbers we have. We've got natural numbers, okay, and they're denoted n, and that's what we have right here. Now natural numbers, that would just be the likes of my counting numbers. Okay, so natural numbers starts number 1, 2, and all the way up. So just our counting numbers would be our natural numbers. We've also got our integers. They're denoted z, and that would be both our positive and negative whole numbers. So that would also include the negative numbers. So for example, -3, -2, -1, 0, 1, 2, and so on and so forth. And then the third type we normally have is our real numbers, and that's denoted or. Now our real numbers includes everything in between all them numbers. So for example, all the decimals, all the reoccurring decimals. So it would include the likes of pi, it would include fractions, it also includes then everything that we have above there, such as 1, such as 3, such as -2. It basically includes everything. Okay, so that would be all our real numbers. So if we're denoting them on number lines, if we're doing on our natural numbers, we would only shade in the actual numbers. So the natural numbers would be, say for example, if it was 1, 2, 3, okay, that would be our natural numbers. On the other hand, if we were plotting our integers, our z's, we'd also include 0, -1, -2, and of course this just depends on what the question asks as well. And if we were plotting our real numbers, we shade in everything because it includes everything in between. Okay, so again, we'll try 2 questions here in a second and you'll see what we mean. So now back to our question at hand. We've 5x minus 3 greater than or equal to 12, and x is an element of the real numbers. We're just worried about this here. Don't worry about the x element, the real number, or the natural number, sorry, yet. Just worry about this part here. So we'll write it out first of all. 5x minus 3 greater than or equal to 12. Now we treat this greater than or equal to just like an equal sign. So the same rules apply. Anytime I bring anything over, it changes the sign. Okay, and multiply becomes divide and divide becomes multiply. Everything is exactly the same, okay, like an equal sign. So we want to try and get all our numbers over to the right hand side and keep anything with a letter on the left. So I'll put in my sign first of all here. Leave my 12 where it is. Leave my 5x here. And we're going to bring over the -3 across like an equal sign. It is a -3, so it comes across and of course becomes a +3. So now I have 5x greater than or equal to 15. So now I know if 5x is greater than or equal to, I have to find what x is. So again, use our same rules we have in algebra. When I bring a 5 that's multiplying over one side, it becomes a divide. So now I'm left with x is greater than or equal to 3. So now we're going to do our number line. So now my number line is drawn. As you can see here, x is greater than or equal to 3. So basically, if you look what way this, I suppose a crocodile's mouth is looking, it's going to the right hand side. So it's going this direction here. Okay, that's the direction it's going there. It's going in this direction here. Alright, so we want to find, so basically what it's saying here is x is all the values greater than or equal to 3. So what are all the values greater than or equal to 3? 3, 4, 5, 6, and on and on and on. So we're going to shade in them numbers there. So it includes the number 3, it includes the number 4, 5, 6, and then this here tells us that it continues on because it's all the numbers greater than 3 that are natural numbers. And remember, natural numbers are just our counting numbers. So that's the first one done. So now we're going to look at a double inequality there. So we've -5 less than 1 minus 3x less than or equal to 10, and x this time is a real number, so that means all the values that we get, they're all real numbers, so it includes everything within, well, whatever else we get here. So some people might remember the way we do these is we put a line down the middle, and on one side we have -5 less than 1 minus 3x. And the other side, we keep the 1 minus 3x there as well. And it's less than or equal to 10. Okay, so you can probably see there that our 1 minus 3x carries on both sides of the equation. Okay, so we're going to solve the left hand side first. We always try and keep the x's along this line here. So whatever our x is, keep it along these lines here as we solve down. So the first thing that happens here is we're going to bring our 1 across the equal sign. So it says it's minus 3x less than, and it comes minus 5. And because remember this is a plus 1 here, so it comes across and becomes a minus 1. Okay, so we have minus 3x less than minus 6. Now, we want to get what x is. Whenever we divide by a minus, okay, so remember this is multiplied on this side, so we're going to bring it across and divide. We also have to change this. We turn it around. Okay, so whenever we're dividing by a minus, we turn this in the opposite direction. So what that means is this goes that way there. It stays as an x. We get minus 6 divided by minus 3. So x is all the numbers greater than 2. Okay, so now we're going to go on the far side here now. We're going to do something similar. So we have our minus 3x again stays where it is, and our 1's going to come over and it's going to become a minus 1. So we have minus 3x less than or equal to 9. So again, we're going to change direction. Greater than or equal to 9 divided by minus 3. So x is greater than or equal to minus 3. So now what we're being told here so far is that x is all the numbers from 2, but not including 2, but greater than or equal to minus 3. So we can actually switch this around, we can. And it'll probably make a lot more sense when we switch it around, because remember on our number lines, our minuses are always to the left and our positives are always to the right. Okay, so if we switch this around here maybe a little bit, it would make a little bit more sense, but we don't have to, because we're just being told x is all the numbers between 2 and minus 3, or between minus 3 and 2, including minus 3, but not including 2. So we don't have to switch it around. So let's just do our number line. So I'm going to put maybe 0 here in the middle. 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. And that's now plot in our points. So it includes the number minus 3. So we can shade that in. Okay. But it doesn't include the number 2. So what we do in this case here, and this is only for when it's a real number, okay, what we do in this case here is we circle the 2. We're going to circle it. Okay, so it doesn't include the number 2. Like it includes, if you think about 1.99, but it doesn't include exactly the number 2. So it includes everything in between these 2 points because it's a real number. So we shade in everything in between them points. And that's it done.